All right, Stats Explorers coming at you with lesson 7.4. We're going to continue our confidence intervals using proportions. Quick overview here, and then we're actually going to do this activity in class using on random.org website. We're going to apply a 4-step process to construct and interpret a confidence interval for population proportion. And then that's going to be kind of a review from the last video. We're just going to put it into a process for you. And then we're going to determine a little bit of new stuff, determine the sample size required to obtain a certain confidence level, confidence interval with a specified margin of error. So if we know the margin of error, what does our sample size need to be? We'll talk about that real quick at the bottom of this page. So the goal today is to figure out what proportion of the Earth is covered by water. If we had a globe that we could throw around, we would pass it around and kind of take a sample like that. We're going to use random.org in class and collect some data. So we're skipping ahead here because we'll fill in our p-hat as a class. We're just going to fill in all the basic stuff here that we can. So we're going to first, our 4-step process here. Our first one is state the parameter you want to estimate and our confidence level. So we want to construct a 95% confidence interval to estimate the proportion of the Earth that is water. So our parameter here is P, and that's the true proportion of the Earth that is covered by water. The confidence level we're asked for 95% confidence level. Our next step is to plan, identify the appropriate inference method, and check the conditions. So our procedure that we're going to be doing here is a 1-sample Z interval for P, which is proportions. The conditions we need to check, we need to check randomness. So we are randomly selecting locations of Earth. So we can put a little check mark there. Let me get and then we want to check our normal. So to check normal, when we have proportions, we're going to check our large counts. So that'll be n times p hat, which will be 50, which we'll check. We don't have either of those right now. And then n times 1 minus p as well. So as long as both of those are greater than or equal to 10, then we can say we are good to go. So we're looking to make sure that this is greater than or equal to 10, greater than or equal to 10, and we can say that we assume that it's normal. So next we'll actually we'll perform the calculations. So our general formula for confidence interval is going to be our point estimate, which in this case is p hat. I guess we got to put some hats on our large counts as well. And then plus or minus our margin of error. Let me go back and put some p hats in here. We need a p hat there, and our point estimate there. Now we're going to rewrite that. We don't need that p hat there. We're going to rewrite this down right below. So the specific formula is p hat, and then we are going to add and subtract. I keep doing that one. And I'm just going to write this out. You can use the equation editor to write this out. We want our critical z value times the square root of p hat times 1 minus p hat, all divided by our sample size. And we learn that, or we know that that's our standard deviation. We talked a little bit about z-scores last time in class as well. So we'll plug our numbers in. We'll plug our p-hat values in, our z-score that we want for 95%, our p-hat again, and divide by our sample size. And we'll get an interval down here. And then finally, we want to interpret our interval. So we will say that we are 95% confident that the interval from whatever we're talking about to wherever we're talking about captures the true proportion of earth covered by water. All right, so the final question here is how many locations would we have to sample if we wanted our margin of error to be only 2% and have a margin of error of 0.02? So I rewrote what the margin of error is here. Something you may see instead of that Z with the apostrophe is this Z sub C for a critical Z score there. I also rewrote it up here too so that it could look a little bit better up there as well. So we want to find n. Notice where n is. N's in the denominator of a square root. It's kind of ugly, but what I'm going to do right now is kind of solve for n. So if you don't want to see a derivation, you can just skip ahead to the actual values and we'll plug in some values and actually solve for what n needs to be. So I'm going to open up a new tab here and get something I can write things out on. All right, it took me a while, but I realized that the video was not recording on the other screen, unlike my previous videos. So take a look here, number 4, our margin of error. We started with E, margin of error equals this Z critical score multiplied by our standard deviation formula. We want to solve for n. Maybe I'll make another video showing how to derive this, but we basically get out of the square root and flip it around a little bit. And what we would do is we plug in our sample proportion here and here, our critical Z score based on our confidence level, and then the margin of error that we want, in this case, 0.02. So you should have your critical Z score based on 95%. You should have a sample proportion from our class, and then we're going to plug those values in here and make sure our math is all good and get a value. And we want to make sure that we round up. If we round down, then our margin of error will be off. If we round up, then we're making sure our margin of error is smaller. So make sure we're rounding up there. If I want to do this right now and I didn't have a sample proportion, I would use 0.05 or 50% as a sample proportion. So to finish this up, we're going to kind of put this again down here, and also our steps, our state, plan, do, and include are going to go in our important ideas box. So let's start filling that in here. So first we state, and that's we want to state our parameter and our confidence level. And then we plan. We want to name the procedure we're doing and check our conditions for random and normal. Next, we want to see the general formula, specific formula, plugged in numbers, and then the final confidence interval answer. And then we want to conclude, and by that we're going to interpret our confidence interval. So state, plan, do, conclude. And we just did very similar to, that's funny, very similar to what we just did previously. Wonderful. So our second learning target was determine the sample size required to obtain the specific margin of error. And basically we want just that formula right there. That'll help us out. Let me go and capture that so I don't have to retype everything in. make it a little smaller to fit here. And add a couple notes. We're going to use p hat is 0.5 if p hat is unknown. Round up. And then there's more information on the previous page about p hat being the sample proportion, margin of error is E, ZC is our critical score. It can also be Z with a little asterisk on it. And we'll plug all our values in and do the math, and we'll round up. We're trying to find our sample size to get our specified margin of error there. And we'll practice this in application 7.4, and then you should be able to do your work in class.